Hi, welcome to this second session on Juniper Networks Mist AI or Artificial Intelligence cloud-based solution. During this session, we are going to be covering the SLEs or service level expectations, which are offered by the Mist solution. My name is David Townsend. I'm a partner sales engineer here at Juniper Networks. And I'd first like to thank our partners at Hardware for organising and hosting these series of webinars. And if you have any queries, any questions, please reach out, ask the experts at Hardware on sales@hardware.com, and they'll be very happy to answer your questions. So let's begin. There's no fixed agenda for the next 25 to 30 minutes, but following on from the first session, it's of course a good idea to have a quick refresh, to have a quick recap on what we have covered so far. And to refresh yourselves, what is Mist? Mist is a cloud-based microservice solution with artificial intelligence at its core, at its heart. And because it is cloud-based and running with microservices, it is available 24/7, 365 days a year. And because of the microservices architecture, we can drive weekly updates with zero downtime. So Mist and its capabilities can keep up with your network changes. And within the Mist, we have a range of different options, such as Wi-Fi assurance, wired assurance, and WAN assurance, as you can see here. Essentially, these allow you to monitor the experience of the users, of the clients who are connecting to the wireless network, connecting to the wired network, and being connected over your SD-WAN. And as such, Mist is the only solution which can provide client to cloud visibility into experience. And using artificial intelligence, AI at its core, we can also use the AI and all its rich telemetry to proactively monitor the network and ask human-based questions via a virtual network assistant tool called Marvis, which is going to be covered on the third session. But first, and following on, let's cover what this session is all about. This session is all about the service level expectations. Now, there are a variety of different SLEs for wireless, for wired, for WAN, for location, and even down to client level visibility. And you're going to be seeing this on a live demo, which will be recorded for this webinar. And you can actually see from the statistics that there are a lot of users who are using Mist, 4 of the Fortune 10, 40% of the Forbes 1000. The statistics read for themselves. These people, these users are using Mist successfully in their network for client level visibility, for using its artificial driven operations, for location based relevancy, and this cloud based architecture. So first SLE or service level expectation is wireless. And as you can see, there are several different wireless SLEs. And we have SLEs which cover successful connects, i.e. is a user connecting successfully to the network, yes or no? And if they are not connecting successfully, why are they not connecting successfully? And here we actually break into different classifiers, i.e. DHCP, authorization, association, and there's more. Time to connect is if you have connected successfully, how long is it taking you to connect? And we also break this down into different classifiers, DHCP, authorization, association, how long does it take you to access the internet services? And once you are connected successfully and within a defined threshold of time, we can then monitor throughput, the coverage, i.e. is there any asymmetry in the downlink or uplink? We can also monitor the capacity for Wi-Fi interference, non-Wi-Fi interference, roaming when the user, a portable user, of course, is roaming between different access points. Is it fast? Is it slow? Are we getting sticky max? And of course, the AP uptime. So you can see here, just within one license, you are getting a lot of information within just the wireless SLE. And then there's the wired SLE, service level expectation. Now this is for your layer 2 LAN, for the EX switches, and in some cases the QFX switches. And ultimately, if we look at a switch, any switch, 12 port, 24 port, 48 port, etc., across the network, there are of course hundreds, if not thousands, of different ports. And using Mist with the wired SLE option, we can identify any issues on any switch within any site, any organization, down to the port and even the client, and identify how is that user's experience being impacted. Is it down to configuration? Is it down to a bad cable? Is it throughput? Or is it down to the switch itself? Is the switch becoming overloaded? Is the CPU running too high and the switch is starting to drop out in terms of performance? We can monitor for storm control, broadcast, unicast, and multicast excessive traffic, i.e. bun traffic, and answer the question ultimately, how is the user's experience? What can you do to increase that experience of the user, to give them a better experience? And then we have the WAN, the SD-WAN service level expectations. And just as we do for the wired, we're ultimately asking the question here, as the users are connected through the SD-WAN, how are the applications? How is the SD-WAN itself? How is the network? How is the interface? And using all of the telemetry that we get from the session smart routers and the SRX gateways, which are connected to the Juniper Mist solution, we are able to monitor the experience of the applications, the latency, the jitter, and the loss down to specific applications, and you can define your own as well. We can monitor the link health of that WAN, and we can also monitor, just as we can with wireless access points and switches, what is the gateway's health? Is it becoming overloaded? Does it have the right amount of power and memory, or is memory being exhausted? And all these are classifiers of how a user's experience could be impacted as the application is traveling to the cloud. And through these three types of SLEs, these three licenses, wireless, wired, and WAN, is how Mist can monitor the experience all the way from the client all the way to the cloud. And as you can see here, we are just breaking down into the different applications, classifiers, sub-classifiers, so you can see actual peer paths going down, the application health as well, and even down to the interface on the Great Gateway itself. So it's really allowing any user to identify very quickly what the experience is, and if it's not as it should be, why is it not as it should be, and investigate and remediate as quickly as possible. But that's enough time of me showing slides. Let's actually go through a live demonstration of the of the service level expectations. So here is the live demo of Mist, and you can see I have the wireless option selected, and I am currently monitoring the last 7 days of telemetry, all state of information which are within this specific site live demo, or I could do it for a specific organization, access point, or even down to a client level. And as you can see, I have the last 7 days of data. And that might not sound like a lot, but every 2 seconds, every access point, every missed access point for every client is sent up 150 plus states of information to Mist, which it is recording. And when you push a button for an analysis, for a calculation, Mist will drive through all of the last 7 days of information using AI to determine these statistics, and you're going to see how we can drill down. So for the last 7 days for this site, I can see, yeah, time to connect is good. It's running 85% success. Roaming, yeah, that's good. Capacity, AP uptime, all of these are good, but there are 2 of which concern, i.e. throughput and successful connects. Because of time purposes, we're not going to obviously be able to go through these and even wired and the WAN SLEs, but we'll focus on wireless SLEs. Of course, if you do want to see more, please get in contact to the experts at sales@hardware.com. So if I click successful connects, we could see 51% are only connecting successfully. So out of the users of the last 7 days, 19, 11, and so on and so forth users, and this is a live office, and for obvious reasons, COVID, there's not many users in the office right now, but only 51% of the users are connecting successfully. So if I actually click on successful connects, it then breaks down into the classifiers, i.e. why are 49% of users not connecting successfully. And out of that 49%, we can see most, i.e. 99% of those 49% of people not connecting successfully is due to authorization. The number one networking fault is still human error. Now, this might be because a user has configured changed the password on the network on the wireless LAN, or maybe someone's not entering in correctly. Authorization, passwords, DHCP, ARP, DNS, and association we can also see here as well. So is the user getting a DHCP address, DNS being resolved, ARP for the IP to MAC address, and association, of course, associating to a wireless LAN. But we can see here that this success rate, as a summary, is only 51%, which we can see, and it's impacting 50% of users have fallen below the service level go, which is a threshold you could define independently for each metric. And ultimately, this is impacting 10 out of 11 or 91% of access points. On timeline, we can see the time that these different events have occurred. So for the last 7 days, we can see there have been a lot of authorization events, i.e. Incorrect passwords. If I click on distribution, this is really from the network side, so I can see what wireless LANs are experiencing unsuccessful connects. I can also see the access points, device operating systems, device types, wireless bands. I can also see something here called anomaly. Anomaly is the event, authorization in this case, is it getting better or worse over time? And you can see here, generically speaking, if it's 1.00 plus, it's getting worse over time. If it's 0.99 or below, it's getting better over time. So we can actually see that these 3 access points, Marvis, support, and testbed, they are increasing with this specific authorization event over time, whereas the other wireless access points are getting better over time in terms of authorization connecting successfully. But this is really from the network side. If I go into affected items, what we can see is that we are now going down to users. So distribution is more the network, the access points, the wireless LANs, the frequency bands, the operating systems. Whereas affected items is the users, the applications, as well as the access points as well. So if I just focus on users, we can see the top hitters right at the top. So we've got this MAC address here, which would normally be someone's name like Denali, Everest, Rosie, so on and so forth. We can also see what their MAC address is, the device type, the operating system on top of that, what's the last AP that they were connected to, and what was the wireless LAN that they were associated to. We can also see the overall impact this is having to their user experience and the failure rate that this is happening at, so 16% of the time. Now, we always like to use Denali. So if I click on Denali, what you're going to see here is a little spinning wheel. That there was AI. That was artificial intelligence. It wasn't the internet waiting for the internet to refresh. That was artificial intelligence correlating and investigating the last 7 days of information through 2 seconds. Every 2 seconds for the last 7 days for that specific user client Denali, and it has determined through all of that telemetry, through all of that information, that actually the number one event, number one issue is not successful connect authorization, it is time to connect. So Denali, they are connecting successfully some of the time, but when they do connect, it is not very fast due to slow association, and it is client specific within the live demo wireless LAN within the 5 GHz band. We can also see that Denali is experiencing throughput due to limited RF capacity, low throughput at only 41%, affecting a small number of clients, again, within the 5 GHz band. And we can also see that there is coverage issues as well. So really, immediately Mist has told me, this user, Denali, they're not having a great time. Their experience is not how we would want it to be for obvious reasons. But does Mist stop here? No, it does not. If I click on View Insights, I then can go into more specific information into the client Denali. For the last 7 days, I can see the transmit, receive, and bytes. I can see the client events. So we have over 2,100 events in total. Some are good, some are neutral, neither good or bad. Most are bad. We can also see what IP they're currently connected to. So right now, Denali's in the kitchen with this IP address, the latency through DHCP, receive signal strength indicator. So this is a pretty good signal. The number of spatial streams, what protocol they're currently running, 82.11ac, the subnet, the gateway, the DNS servers. But what might be sticking out to you is, this is a success. Either user has obtained a DHCP IP address successfully. Great. But you can actually see below here that, this was denied. Well, why is that? Well, as the sayings go, packets do not lie. And an operator might want to actually see, what does the packet say? So what Mist does is when an event happens, like DHCP, like incorrect password, authentication issues, it will capture that event. So I can then download the packet capture to decode in Wireshark or similar, or analyze it using CloudShark. And so an operator team might use this, and I can speak from experience when I used to be an engineer in London, of the amount of times that I had to go onto site, connect a laptop, a tester, and wait for an event to happen, which originally triggered a knock to send me out to site in the first place. And I'm there waiting for this DHCP NAC to happen again. But obviously that takes time and money and the travel across London, the pollution involved in that, etc. Mist does this automatically. It automatically captures only the control information. So I can actually then go into the packets, into the layer 3, into the layer 2 associated headers, and I can see, there's a boot request from this MAC address. It's a malformed packet. They're asking, who has this IP address, 2.1. And eventually going through here, we'll be able to determine, okay, it was a DHCP NAC. Let's close this down. What I can also see was the pre-connection. Before they were connected, what was the authorization latency, the DHCP latency as well. I can also see the post-connection receive signal strength indicator. So we can see the average, the minimum and maximum RSSI, the transmit and receive bytes over time. We can also monitor from a high level here, and I'll show in a subsequent session how you can go into more detail here. But we can also see how Denali is roaming through the different access points. So here we can see, roaming from kitchen to EBC to AP. We can also determine, well, at LD kitchen, live demo kitchen, the received signal strength was neg 65. As I went to here, it went from neg 65 to actually neg 73 dB, neg 69 dBm to neg 73 dBm. It obviously increased here. So that's not a really good roam, is it? But we can then see that they moved back to the kitchen where they got a better roaming experience. And we can also then see further details into Denali itself. And that is just how you can very quickly go from a wireless SOE, such as successful connects, such as successful connects for an entire site to drill down into a specific user. And just to show you, if I go into throughput, we can then go into device capability. Is the device capable of supporting this throughput? We can also monitor for any network issues. What is the coverage of throughput and the capacity? And note that the capacity has broken it down into further sub-classifiers. Wi-Fi interference, which might be DFS, non-Wi-Fi interference, excessive client load, so too many clients are associated to this particular wireless LAN, and high bandwidth utilization. And just as we did before, if I click on the high hitter, Wi-Fi interference and affected items, I can see who again are my top hitters. So I can see Denali is again there at the top, but let's pick on someone different. So let's go to the top hitter, Galaxy Xcover Pro, and note the spinning wheel yet again. Artificial intelligence has summarized that the number one event for this user for throughput is actually throughput itself. So the client is experiencing really low throughput of 89%. So they're only getting 11% of their throughput, and this is due to limited RF capacity. It's client specific, and again within 5 gigahertz band. 5 gigahertz band. So you can see here that you'll be able to determine very quickly that there might be something not right with your 5 gigahertz bands, your 5 gigahertz channels, etc. And using Mist, you'll be able to investigate this. We can see time to connect. We can also see that they're experiencing roaming issues. And just as I did with Denali, if I click View Insights, I then have more. We can see them on the map. This will be session 3. Session 4, where we go to location-based services. We can see, just as we did with Denali, their total events, ones that are bad. We can change these. So these are some of the states of information: the good, the neither bad or good, and the bad. We can monitor this for all APs or specific APs. So the user can only see what they want to see. And just as I did before, I can see, yep, there's a paperclip here. Scroll down and obviously authorization failure, download this PCAP, and then there we go. I have that PCAP for the Galaxy user for this specific event here. And that is just 2 metrics. That is just for, let me change this back to live demo. That is for only 2 metrics for wireless. We haven't even got into wired, WAN, location, insights. Mist provides so many metrics. As you can see, 7 for wireless, 3 for wired, throughput, successful connects, switching health, and all the classifiers therein. There's nothing hidden here. Within the option, you get everything here. WAN, yes, different option, but you can see that there's gateway health, there's application health as well. Location-based insights, so the ability to go into locations as well to see latency, dropped requests, teleports, AP uptime, and all the classifiers and sub-classifiers therein. And as we did, go down to specific clients as well to monitor, or it doesn't have to be clients, it could be access points, switches, gateways, wired clients, Mist edges. Mist allows you the capability to very quickly monitor the experience of your network, of your organization, all the way from the client to the cloud. So that is the end of the demonstration. I hope that you found that useful and exciting. And as I said before, if you have any questions, queries, please ask the experts at Hardware on sales@hardware.com, and of course they'll be very happy to respond to you. And please do look forward to our next session, where I will be covering the Mist virtual network assistant that we call Marvis. That is called Marvis. It uses AI to proactively monitor your network and to give you not indications, but to give you actions, as the page shows here, on what you need to do as an operator, as an administrator, to increase the performance of your network, to increase the experience of your users over your network. And you can even, as you'll see next week, ask human-based questions. How is my site? How is Denali? How is this user? What is the roaming like? And you'll see all of this next week. Marvis is very unique, very powerful, and it is driven by AI. And as I said at the beginning, AI is at the core. It is the beating heart of the Mist solution. Thank you very much for your time. Thank you for listening, and I look forward to presenting the third session in due course soon. Thank you very much. Goodbye.